welcome to the Science 1 class. In this video, we are going to learn about the extractive metallurgy of iron. Next to aluminium, the most abundant metal is iron. In nature, iron will be found as oxide or sulfide or carbonate. The important ores of iron are hematite, Fe2O3, magnetite, Fe3O4 and iron pyrite, FeS2. The chief ore of iron is hematite. Let's learn how iron is separated from hematite, and it involves three steps: concentration or ore separation, roasting and calcination, and smelting. First, concentration is done by gravity separation method. Already we have learnt in detail about the gravity separation method in the metallurgy video. That is, when water is allowed to flow through the ore, the lighter particles or gangue will be washed away by the water, while the heavier ore particles will settle down. Now, let's move on to the second step, that is roasting and calcination. Roasting and calcination are done in a furnace called reverberatory furnace. For aluminium and copper, blast furnace is used, and for iron, reverberatory furnace is used. Here, in the presence of air, that is, in a limited supply of air, when the ore is strongly heated, the moisture present in the ore will be removed, and also the impurities like sulfur, arsenic and phosphorus will be oxidized and removed. Next step is smelting. Smelting is done in a blast furnace. In the blast furnace, the roasted ore obtained in the roasting process, along with the ore, coke, that is carbon, and limestone, that is calcium, are added through a cup-like arrangement present at the top of the blast furnace in a fixed ratio 8:4:1. In the blast furnace, three regions are there. They are lower zone, middle zone and upper zone. In each zones, different temperatures will be maintained and different reactions will take place. That's why they have divided into three zones. Lower region is called as the combustion zone because here the temperature will be higher, that is 1500 degrees Celsius. In 1500 degrees Celsius, the coke in the blast furnace will combine with the oxygen and burn to form carbon dioxide. This is an exothermic process. Hence, the heat will be liberated and the temperature will be higher. Next one is middle region, and the middle region is called as fusion zone. Here, the temperature will be lower than combustion zone, that is 1000 degrees Celsius. The carbon dioxide formed in the lower region will combine with coke and burn at 1000 degrees Celsius to form two molecules of carbon monoxide. During this reaction, heat will be absorbed because it is an endothermic process. Limestone, CaCO3, in the presence of oxygen and heat will give calcium oxide, CaO, and carbon dioxide. This is also an endothermic process. Hence, the heat will be absorbed. In the middle region, both the reactions are endothermic. Then The calcium oxide CaO will combine with silica SiO2 to form calcium silicate CaSiO3. Next, upper region. Upper region is called as reduction zone. The temperature will be very low, that is 400 degrees Celsius. Here, the carbon monoxide will convert ferric oxide Fe2O3 into iron. The iron obtained here will be spongy. This molten iron will be collected through the bottom of the furnace. This iron is called as pig iron. Carbon content will be higher in this iron. When we melt this iron, that is pig iron, and cast into different molds, we will obtain cast iron. Now, let's learn about the physical properties of iron. It's a lustrous, that is shiny, grayish white metal. Tensility, malleability and ductility will be higher as other metals. The special property of the metal iron is it can be magnetized. Next, chemical properties of iron. Reaction with oxygen. Iron on heating with oxygen will form magnetic oxide Fe3O4. The equation is iron Fe plus oxygen O2 will give magnetic oxide Fe3O4. And the color of the magnetic oxide is black. Next, reaction with moist air. This is an important reaction. When iron is exposed to moist air, a brown layer will be formed on its surface. And the brown layer is called as hydrated ferric oxide or rust. And the phenomena is called as rusting. The equation is iron Fe plus oxygen O2 plus water H2O will give hydrated ferric oxide Fe2O3 dot XH2O. X can be any number of water molecules. Next, reaction with steam. When we pass steam, that is water vapor, over red hot iron, magnetic oxide will be formed. The equation is iron Fe plus steam H2O will give magnetic oxide Fe3O4 with the liberation of hydrogen gas H2. Next, reaction with chlorine. Iron will react with chlorine to form ferric chloride. The equation is iron Fe plus chlorine Cl2 will give ferric chloride FeCl3. Next, reaction with acids. With dilute hydrochloric acid HCl and dilute sulfuric acid H2SO4, hydrogen gas will be liberated. Generally, when metals react with acids, will liberate hydrogen gas. First, reaction with dilute hydrochloric acid. The equation is iron Fe plus dilute hydrochloric acid HCl will give ferrous chloride FeCl2 plus hydrogen gas. Reaction with dilute sulfuric acid. The equation is iron Fe plus dilute sulfuric acid H2SO4 will give ferrous sulfate FeSO4 plus hydrogen gas. Reaction with dilute nitric acid. The equation is iron Fe plus dilute nitric acid HNO3 will give ferrous nitrate FeNO3 twice plus ammonium nitrate NH4NO3 plus water H2O. Reaction with concentrated acid, that is concentrated sulfuric acid H2SO4. The equation is iron Fe plus concentrated sulfuric acid H2SO4 will give ferric sulfate Fe2SO4 thrice plus sulfur dioxide SO2 plus water H2O. Reaction with concentrated nitric acid HNO3. When iron is dipped in concentrated nitric acid HNO3, it becomes inert, that is, will not react. And it's due to the formation of iron oxide Fe3O4 on its surface. Uses of iron. Depending on the content of the iron can be classified as pig iron, steel and wrought iron. Pig iron. Iron which contains 2 to 4.5% of carbon is called as pig iron. It is used for making pipes, stoves, radiators, railings, that is fence made of metal bars, manhole covers, that is a removable metal plate, and drain pipes. Steel will contain only less than 0.25% of carbon. It is used in the construction of buildings, machinery, transmission cables, TV towers, and in making alloys. Wrought iron will contain 0.25 to 2% of carbon. It is used to make springs, anchors, and electromagnets. Okay students, that's all for today's class. In this video, we have learnt about extraction of iron, physical properties, chemical properties, and uses of iron. Thank you students. Have a good day.